Alright, so let's take a look at the new ElboPipe item assembly preset. It's a preset designed to create a particular kind of piping, piping that consists of straight segments with relatively short, tight turns and with optional elbow geometry on those short, tight turns. And while we call this a MeshFusion item assembly, I would note that it's really just a piping assembly. I've set it up to be MeshFusion friendly, to create geometry that works well with MeshFusion, but it can be used with or without MeshFusion. So let's just go ahead and bring the assembly into our scene. Hit the Add Item button, and here in Item Assemblies, MeshFusion Assemblies, we find ElboPipe. Double click, and it brings the default configuration of the assembly into our scene. So there you can see these are the straight segments, these are the elbows, which are not bent yet because the polyline that is describing this default configuration is currently straight. All of the components of the assembly are in this gray colored folder called ElboPipe, and we see them here. And there's a default polyline called Elbow 7-point line. And if we select that and go to vertex mode and simply select some vertex and move it, you can see the elbow come into play. And it's created simply by some polygon beveling of the geometry that traverses the bend there. So naturally, the assembly can use any polyline as its path, and you can manipulate that polyline any way you like, and get whatever path you like. And you can also do most of the standard editing things you might wish to do with a polyline. For example, I can go to the Edge V-tab here and select Add Point. Click on an edge, and that will add a new point along our polyline, and any point along the polyline gets elbow geometry.
An important note here before we proceed, there is a known issue with the pin extrude tool, which is at the core of this assembly. With certain angles, it can cause the profile to twist, and that creates some serious problems with this assembly because of the beveling of the elbows goes crazy when those twists occur. I will do another quick video that helps you avoid that problem. I just want you to be aware of it so it doesn't surprise you when you first start to play with the assembly.
Beyond the polyline itself, all of the other controls associated with this particular instance of the assembly are accessible through this Elbow UI locator. So we could either click on that item in the item list or click on the locator itself in the 3D viewport. It's attached to the starting end of the polyline. Either way, it brings up this popover form with all of the assembly's properties. So let's take a look at some of those properties. First, we have the profile sides. There's a default profile, which is a circle, and we can simply set the number of sides. And I will note that by default, the assembly is set up to produce a P-subsurface, so we won't see a lot of visible difference as we change the number of sides here. But that is an option. You can also have this produce a polygonal surface, in which case the number of sides might be important. Next, we have the width and height of that circular profile, and I find it handy when adjusting those, since you often want to keep them equal, to just select them both, and in item mode, hit the C key to get channel hauling, and by dragging outside of the channel haul control, you can equally adjust width and height. Now, if we adjust that far enough, you'll notice something interesting happen. We lose our elbows. And that's where a kind of little tricky part of the assembly comes into play. In order to detect elbows, it's really looking at the size of the polygons along the path as the path is processed into a pipe. And it keys off of that in order to determine which polygons to bevel for the elbow geometry. And that measurement of polygon size is what this property bevel select area is about. If we make the pipe smaller and we start to lose that distinction, that means we need to make that target area, size of the polygon, smaller. And if I do that, it will start to recreate the elbows. And it's usually pretty tolerant. It's not like you have to hit an exact number. You just have to play with it, make sure that all of your elbows are present. And then you know you're good to go. Next we have elbow segments, which is simply the number of segments in the curved section where the elbow is. And you can just change that to get as smooth a curve as you want. Again, with P-subs, you usually don't need that to be a very big number. Next we have elbow size, sort of like elbow length. I call it size because really what's going on here is behind the scenes is an edge bevel, and its size is the property that we are adjusting with elbow size. Again, that's a good one to channel haul to get smoother interaction. So you're really increasing the radius of the curve as well as the length of the elbow. Next we have the main bevel shift and inset. These are the bevel properties controlling the main bevel that creates the elbow geometry. And since we made our pipe much thinner just a second ago, maybe we don't want our elbows to be so pronounced, so we can start to shrink that down to whatever we think is appropriate.
You'll note that I'm changing the shift and inset together, keeping them equal. That gives us about a 45-degree angle in the transition between the elbow geometry and the pipe geometry. If you make the inset larger relative to the shift, you'll get a longer, gentler slope in that transition. If you make the inset smaller, it'll become shorter and steeper. These side bevel shift and inset properties are two that you might be happy to never mess with. Really all they are there for is with a P-sub surface, they kind of add a secondary bevel that makes that transition between the elbow and the pipe sharp, relatively sharp, as opposed to just kind of very soft and blobby. So with the settings of 0 in both, that's what you get. You can do some interesting things by changing those settings. It's all a bit quirky because really it's not some sort of direct notion of changing the profile around that area that connects the elbow to the pipe. It's just sort of what you get when you play with those settings. So it might be nice to come up with some interesting ratios, some sort of presets to help you get these sort of rims that you're seeing here. But generally speaking, if you just want a straightforward elbow, you can just leave those at 0. Below that we have curve extrude steps and pin extrude. Normally the assembly is driven by the pin extrude mesh op, but if we uncheck pin extrude, it will use the curve extrude mesh op. And when pin extrude is unchecked, then curve extrude steps becomes relevant. Those steps have no effect on pin extrude, only on curve extrude. And with curve extrude, you don't get any elbow geometry at all. You just get a continuous diameter along the length of your tube, and you also have to set the number of total steps along the length of the tube. Nonetheless, you're still getting the same path structure. You're still getting straight segments with relatively tight turns, and the size of those turns, the radius, is still controlled by the elbow size property above. So similar geometry overall, just no distinct elbows. Naturally, you can go back to pin extrude at any time and the elbow geometry will reappear. The rest is pretty trivial. We have extrude profile flip. You only need that if your tube is inside out. That just flips the profile polygons. Then we have extrude cap start and extrude cap end, which you can use to selectively cap or not cap the ends of the tube. Alright, that about covers the basics, and we'll get into some more details in some subsequent videos. Thanks.